Hello, this is mini lecture number 14. I'm Jess Briesma, lecturing for Computer Science 163 at the University of Wisconsin, Eau Claire. In this mini lecture, we'll be talking about object-oriented programming and classes. The relevant reading for this, if you haven't done it already, is Chapter 9, Sections 1 through 4, and I encourage you to check that out. Before we begin, I'd like you to think about the different kinds of data that we've seen already. So for instance, what are the primitive types of data, like int, boolean, char? And so besides those, what other types of objects have you seen? As a hint, there are two that we've looked at in a little more detail. One has to do with text, and the other one is similar to an array. So what other types of objects have you seen? And then also, what other objects have you seen that don't really seem to have a type? If you had to think about them, you don't really know what type they are. Object-oriented programming. This is a major programming paradigm that is not unique to C++. Java, Smalltalk, and many other languages actually have this concept of using objects to program. And the reason that that's so cool is that it makes things more natural. It makes programming a little bit less arcane, perhaps, when you talk about objects. And we'll talk about what that means and why that is in a moment. So why object-oriented programming? What is it? Well, as programs get larger, it's really hard to maintain, let alone comprehend, dozens, hundreds, or even thousands of functions from increasingly specialized tasks. So if you were to open the source code for, say, Microsoft Office, which uses C++, actually, it would be really, really hard to know what's going on, except that it uses object-oriented programming, which makes it a little bit easier to figure out what's going on at different parts in the program. So object-oriented programming uses objects to represent entities in the real world. So for instance, I could have an apple, and I could program an apple and say, here's the color, here's the type of the apple, maybe here's the size or the weight of the apple. So objects can contain data. Objects can also have functions attached to it. And we'll see some examples of what that might be like in just a moment. There's also a really strong motivation for using object-oriented programming, and that's described by something called encapsulation, which I'll talk about in just a little bit. Some more benefits of object-oriented programming. You can define objects to describe the important parts of your program. So instead of just having like 1,000 functions just floating around in your source code, all in one big file, it's helpful to be able to make your code more modular by organizing similar pieces of code into objects and thinking about what kinds of objects are there in my program and how could I represent that as an object in my code? What does that mean? But it's helpful because it helps organize your code. And then here's the kicker. You can delegate tasks to those objects rather than doing everything by hand. So not only can you store data in an object, you could also tell objects to do different things. So you over there, do this thing. Object A, what's your status? It's like when you ask an F stream or an IF stream. Are you good? Did you open the file correctly? There was that dot operator. And so that dot operator is asking a question or sending a message to the object before the dot. So vector, please add this object to yourself. So if we had some vector called myvec, a vector of doubles, we would do like myvec dot pushback. Pushback is a method that you're message that you're sending to that vector. So by creating an object for almost every noun in your program and methods as the verbs in your program, we can make programs flow more like natural language. It's not really natural to be talking about the world in terms of ints, booleans, strings, characters, doubles. That makes sense for a computer program, but it's not really natural for us as humans. It's more natural for us to think of objects, shapes, letters, boxes, things, emotions. So those are all things that you can actually program and code in some way and relate to each other. Encapsulation. I told you I'd get back to it. Encapsulation is the practice of stuffing data and methods into an object. So maybe taking a bunch of variables that describe an entity in your program and then combining them and creating that entity and then writing methods that will operate on that entity or send messages to that entity. This hides complex details from those who are using that object. So for instance, when we use the IOStream in vector objects, like cout, for instance, was an O stream, cin was an I stream, and when we used vectors, we didn't have to know how it was doing the things that it did under the hood. When we used a vector, we didn't know whether it had an array under the hood, though I told you it did, or what other variables that it has underneath the hood. All you needed to know was that a vector is kind of like an array, and I can use it like an array. And this is good, because if you'd known all the inner workings, it would have, one, probably been overwhelming or more confusing to you, but then two, if we knew what was going on and we tried to mess with it, it could actually mess it up. So instead, the writers of the vector class actually provide us with a couple specific functions, like push back if you want to add something to the end of a vector, push front if you want to add something to the front of the vector, and so on. So this is really handy and a good practice because it keeps your code more safe. So if you do want to let users access certain parts of your code, you can give them access using methods, or a function. And ultimately, what's another benefit of encapsulation is that this lets developers, the people writing this object or entity, it lets them update the implementation of that object without it affecting how users who are actually using the object. So in other words, the people who are writing the C++ vector class, they could have totally changed how a vector class works under the hood, and we'd never know because we're still using the same functions as what they provided us when they first wrote it, which is pretty cool. Now here's a little bit more of a concrete explanation of what encapsulation is. When you look at the dashboard of your car, you see all these little dials and lights and gizmos and gadgets and whatnot, right? And we know what they mean, but I don't know about you. I don't know exactly how. I've got a master's in physics. I don't know exactly how a speedometer works. I can give you a pretty good explanation of roughly how it works, but ultimately I don't know exactly how it works. I don't know how the gas gauge works. I don't know how the oil gauge works. I don't know how the RPM gauge works, though I have a pretty good idea. I can guess, but ultimately they're black boxes to me. And that's because whoever was designing this car, which is a 2016 Toyota Corolla, a nice car, whoever was designing this car was actually, they know that the driver doesn't need to know all those details about car design in order to use these dials. And so what they've done is they've encapsulated all of those details and given us this little user interface to be able to use. That makes things a whole lot easier for us as the user of the car, and it makes it, I think it makes it really elegant too. By taking away all those details, it makes it nice, streamlined, and simple, ultimately. What is a class? You heard me mention that just a moment ago. A class is a compound data type that provides functions for variables of its type. So in C++, when I talked about making objects, to describe entities in the real world in your program, the way that we do that in C++ is by creating a class for that object. So this is how we define an object in C++. And the motivation? One is we want to be more object-oriented, and ultimately, we want to be able to better represent real-world objects as variables in our code. So for instance, like in our textbook, chapter 9, it uses the example of like a bank account or a cash register. You could also create an object called like a worker. You could have different kinds of workers. You could have a building. You could have different kinds of buildings. And a building is, a subcategory of like a box or a shelter or a structure or something. And so you can have all these different things, and every one of those nouns that I mentioned are different, they could be represented as different classes, which is kind of cool. Now when we do that, we're going to put in data, we're going to give each of those objects or each of those classes variables that belong to it. So for instance, for a bank account, we could give it a balance, which would be like an integer number of pennies maybe. We would give it maybe an account number. We could give it a name associated with that bank account. And we could give it all these other different kinds of data that might pertain to that. A string representing the name of the bank of that bank account, a string representing the password or username. So we could do all that, and we could create like a bank account object, which is kind of cool. And then we could create methods or functions that would act on that, like withdraw money from the bank account, deposit money to the bank account, check if this username matches that other username, stuff like that. Let's see some examples of classes that you're already a little familiar with. The first one is the string class. Now I've told you that classes have data and they have functions, or methods. Some of the data in the string class that's hidden from us is the length of the string, and then also this thing called char star data. Now that is actually related to pointers. It's a C-style string, a pointer to an array of characters. Don't worry about that too much under the hood. That's details that I wish we had time to cover in our class, but we just didn't because of COVID-19. But anyway, so that's it's basically saying here's the text, and then here's the length of the string. And there's a bunch of other data underneath the hood of the string class that we just won't. Just for simplicity, let's keep it at this. Some of the functions that the creators of the string class provide to us are the following. Length, if you want to see how long your string is. Clear, if you want to remove all the characters and text from a string all at once. Swap, if you want to replace the contents of one string with the contents of another string. Copy, if you want to copy the contents of one string to another. So these are some useful things that you can do. Each one of those sends a message to a string variable saying, hey, tell me your length. Hey, I want you to replace your contents with these contents from another string, and so on. So it makes things nice and easy to use. Another class that we've seen is the vector class. Now, before I go, try to think about what some of the data might be under the hood of the vector class. Remember, it's kind of similar to an array. All right, in 3, 2, 1, I will move on. Some of the data are these. One is this data type star array. Again, that's a pointer to a dynamically sized array, which is a little bit beyond the scope of what we're doing. I really wish we had had some time to talk about dynamic memory and pointers. We didn't, I'm sorry, COVID-19. But it's basically a special kind of array. Then we also have something called length, the length of the array, how many things are actually stored in it. And then int capacity. It turns out that the array will actually create more space than there are elements in it. And that makes things speed up in the long run because it takes a lot of time to shrink or resize an array. But if you've got, it's really quick to add something to the end of the array. So it keeps track of not only its actual length, but also how big is the array under the hood. And again, those are things that you don't want to have to worry about as the user. This is something that the people who wrote the class did, and they're hiding those details from us, which is encapsulation. The functions that you can use on the vector class, here's just a couple of them. You can ask a vector, what's your size? What's the maximum size, i.e. what's the capacity? Can you reserve some space? Say, hey, I know, right now I only have 5 objects in my vector, but I know that I'm going to need 100 objects later. Can you reserve that space now? Push back, can you add something to yourself vector? Vector, what's the element at, index 3? Hey vector, what's, at the front? What value is at your front? And then, hey vector, could you just clear yourself? Just remove all elements in you. So these are a bunch of the different functions that the vector class can do. Next, we have the OStream class. So I'm not going to worry about exactly what's under the hood. There's a lot of things. It turns out it's a pretty complicated class. But there's format flags. How wide am I going to have output numbers? How am I going to include the sign in numbers? Am I going to do it in scientific notation or some other notation? Am I going to do it in hex or binary? So there's a whole bunch of formatting that it does. There's error state information. Am I connected to an output source? Am I disconnected from an output? Is the file open? Is the file not open? And there's a whole bunch of other ones too. It's a complicated class. Again, I'm glad that we don't have to worry about all the details of that. Instead, we just have to worry about some of the functions that the writers of that class gave to us, including flush. Remember what that does with the stream? It makes all the data move in the stream to its final destination. Write, if you want to write something to the stream. You can get certain flags from the stream, and you can get the state of the stream using these different these flags too. And there's a bunch of other ones too, like the insertion operators, the extraction operator for like cout and cin. Those are all defined here too. Let's move on to some terminology. Now, when we create a variable or create a class, we're going to give it some member variables. These are also known as instance variables. That's what I learned. That's how I like to refer to them. but sometimes you'll hear them called data members as well. They're all referring to the same thing. It's the variables that are contained in each object of a given class type. So if I create a new class called fruit, then the variables contained in that fruit might be like the color of the fruit, the type of the fruit, the acidity of the fruit. I don't know, something like that, right? It's the data that you would give to that object. Member functions, which are also called instance methods, are the functions or methods that will operate on each variable of a given class type. So for instance, with the vector, the member functions were the functions like pushback or size, and so on. Now there are things called private and public. A private, you can specify each instance variable and each instance method to be either private or public or protected. A private variable and function are hidden from the end user. They don't have access to them. No other class, no other code anywhere will have access to them except functions that are part of that class. Now, public variables and functions, on the other hand, you have full visibility. So that means that any other bit of code can access those methods or variables and modify them. In other words, the details aren't hidden. The details might be a little bit encapsulated in the sense that, well, they're stuck in that class, but it's like the class is surrounded in a clear shell. You can see all the innards, you can poke them, you can prod them, you can change them as you want. And maybe that's good, maybe it's bad. It's not very secure if you're security-minded. There's also something in the middle called protected, and protected variables and functions are visible only to this class and its subclasses if you extend the class. Now that's something we're not talking about here so much, we'll talk about a little bit later, but that's just something that you might see and I wanted to point it out. It's kind of in between public and private. There's also this idea of a constructor. When you create a new object, you construct that object. So if I create an int, for instance, in my main method I say int I equals 3. There's no constructor because an integer is a primitive type. It's the lowest level, most basic kind of variable that there is in C++. But when you have a class object, you need to initialize the data variables, the members, the instance variables of that class object. So to do that, we use a constructor, and the constructor is what initializes your variables. So a constructor is a method for every class that tells how to build or how to initialize that object. Now let's actually take an example here. Let's say that we have to do a lot of work with rectangles in our program. So we have to work with rectangles so often that we're like, let's build a rectangle class. So I want you to pause now and think, what member variables or what instance variables would you give to a rectangle object? What does every rectangle need to know? Or what does every rectangle need to have? Secondly, what functions or services or methods would you provide to rectangles? What kinds of things would you want to know about a rectangle? What kinds of things might other people want to know about a rectangle? What would you want to change about a rectangle? So I want you to pause here and actually write some of these things down. Well, I'll go through a bunch of them now, and I'll only go through a couple of them. There's a lot more that you could have, but I want you to think about this to help you learn. So I want you to think about that, at least in the back of your mind. We're going to take a quick tack, and we're going to come back to that. Polymorphism. Polymorphism is the ability of a class to take on multiple forms. What the heck? Okay, so poly means many and morph means form, so I get what polymorphism means, but what does that mean about programming? How can a class take on multiple forms? Well, a class can be extended, and what does that mean? A class is called a subclass. So if you extend it, if I have class A and I extend it and create class B extends class A. So class B is called the subclass of class A. So it's the child of class A. The original class is, in our example, class A, is called the superclass or parent class. And here's what's cool. The child class inherits member data, and member functions from its parent class. The subclass is a specialization of the superclass. Okay, Now, this is all well and fine, but I know this is very abstract right now. So what I want to do is I want to use an example here to motivate this and kind of explain what's going on. From that, I hope you'll be able to see what exactly polymorphism is and how it could be so amazingly powerful in computer programming. Here's an example of polymorphism. So let's say that I have a rectangle, I have a square, I have a diamond, I have a circle, and I have a star, a quadrilateral, and a shape. So I've defined a whole bunch of different classes for my geometry program. Why not, right? So what I'm going to do is I'm going to define a class called shape. So class shape, and then curly braces with a semicolon at the end. Don't forget the semicolon at the end of your class. And then I've got some methods in between. And virtual, don't worry about that. That means it's a virtual base class. The equals 0 at the end, again, that means it's a virtual base class. It doesn't mean the perimeter area is 0. Ignore that for now. The point is, a star, circle, diamond, rectangle, quadrilateral, and square, they are all subclasses of the shape. A circle is a shape. A star is a shape. A quadrilateral is a shape. So you can create a star, you can create a circle, and both of those, even though they have different data under the hood, like the star might have how many points do you have, what's the angle of each point, something like that. It might even have like what color is the star. All of those things might be useful information, but they don't pertain to a shape as a whole, they only pertain to a star. So you wouldn't put that information in a shape class, you would put that in the star class. And for a circle, you would have like maybe my radius, maybe my color, maybe my edge thickness if you were drawing or something. But again, those are things that would pertain to the circle, but really wouldn't pertain to a shape in general. A shape doesn't necessarily have a radius, right? But a circle does. And for a quadrilateral, you could have like a rectangle or a diamond. A quadrilateral itself is a kind of shape, but there's a lot of different quadrilaterals. If I told you draw a quadrilateral, you could, but you would really probably be drawing the other things. It's kind of hard to think about what does a quadrilateral have. You'd say, well, what kind of quadrilateral? So you could have like a diamond, and you could say like the angles of the diamond, the edge lengths of the diamond. A rectangle, you could say the width and the height. And then a square, you could just say just the width, right? Or the edge length. So each one of these things has a superclass that they point to using the arrow. So the shape is the superclass of all of these. All of those things are shapes. All of the things with arrows pointing to the quadrilateral are quadrilaterals, and the quadrilaterals are all shapes. And the square is the type of rectangle, and a rectangle is a quadrilateral, and a quadrilateral is a shape. So you could ask any shape things like, what's the perimeter? What's your area? And so every one of those classes then would be able to have methods called calc perimeter and calc area. And that's the defining mark of being a shape. Or a 2D shape, I don't know. Language breaks down, but you get the idea, I hope. And the idea is that a square is a specialization of a rectangle is a specialization of a quadrilateral is a specialization of a shape. They all have things that are in common, and all those common things are in the shape class. But then they all have increasing levels of specialization, and that's what makes them different and what makes them cool. Now I can create a variable called rect my rect, or diamond my diamond, or circle C equals a new circle with radius 10 or something like that. And if I've done this with all the classes, I can do this, and I can ask each of them what's your area and what's your perimeter, and each of those classes will be able to answer and tell me exactly how to do that. So that's what polymorphism does in a nutshell. Here's another example using I streams and O streams that we've seen. So here, an I stream is the base class or the superclass for two other kinds of streams, an IF stream class and the I string stream class. Now, an I stream class, as you remember, is input streams. So Cin is a variable of type I stream. An IF stream is a special kind of I stream that deals with files, so input file stream. An I string stream is a specialization of the I stream class. It's a subclass of the iStream class that deals with strings. So if you wanted to maybe read in data from a string, you could use an iString stream. Now on the other side, we have an O stream, the output streams. So the classic example of an O stream is cout, which you're very familiar with at this point. Now there are two specializations of the OStream class. OStream is a superclass for the OF stream. OF stream is a specialization of the I can't talk. OF stream is a specialization of the OStream class. It's a specialization because it does all the same things that an OStream can, but it deals specifically with files. An OString stream does everything that the OStream class can do, but it deals specifically with strings. So if I'm trying to write to a string, I can do that using an OString stream. Finally, let's get to some quiz and review questions. I know that was a whirlwind, and I wish we had a lot more time to practice and talk, but again, COVID-19 prevented us from being able to quite get there. So I want you to think about these questions, and I've got answers at the very end. These are questions that you might kind of see on the final exam. Here's the quickest practice problem of all of them this year. Suppose that you wanted to write a class to describe a rectangle. What private data members or instance variables would your rectangle object have? And what public methods would you provide so that other people who wanted to use a rectangle would be able to use it? I've already mentioned one or two possible ones when I was talking about the shapes, but I want you to think about some more. What kinds of things would you want to know about a rectangle? So I want you to write these down, and in the next mini lecture, I'll actually go through this in a lot more detail. So stay tuned. Here are the answers to the quiz style review questions from earlier. If you have any questions, please email me, let me know. Contact me on Discord. That's it, so I hope that you enjoyed, and I will talk to you later. Bye-bye.